Okay, today what I'm going to talk about is the gravity model of AP Human Geography, and it is by C.Y. Zhang. And first, let's say who will we first think of when you hear the word gravity? Yeah, Isaac Newton, the man who is hit by the dropping apple. Look at this picture. Yeah, and what Isaac Newton came up with a theory that named Isaac Newton's law of gravitation. Uh, says that when two atoms that who have mass and they will uh, both have a power over each other, and means which means that they have the gravity for both of their each other, and it is depend on the mass and it is depend on the mass of the these two item and depends on the distance between these two atoms. And what is the definition of gravity model on AP Human Geography? It means that it always used to predict the degree of interaction between two places. And it's first been used by Jane Tinbergen in 1962. And it always been used in two cities or central city and even continents. And the gravity model, as social science refer to the modified law of gravitation, takes into account the population size of two places and their distance. Since larger places attract more people, ideas, and commodities more than smaller places do, and the places closer to each other have a greater interaction with each other, and so we can come up with this the gravity model equation. You can see the picture. It is equal to the population of one city times the population of another city, and altogether divided by the distance between two cities square, and which will come out with a number. And this number is the interaction power, or we say interaction number of these two cities. And this numbers is always can consider the traffic flow and the changes people migrated between two areas and many other things about that places. And here is a picture example. First, in this picture we can see let's say it's a green city and yellow city and a blue city. The green city is the biggest and the blue city is the smallest, which means the green one have a greater population, and we can see the gravity between the green city and yellow city is greater than the gravity between yellow city and blue city, which their distance is kind of the same, but their population is very different. But the population of green city and blue city is different from the population of green city and yellow city. But the gravity of these two curves is is almost same, because the distance of the blue city is closer to the green city. Okay, let's interact a real example. Let us consider two famous cities named New York and Los Angeles. We then come out with this equation, a pretty huge number. It is follow this gravity model rules. You can see this number is the population of New York, and this number is the population of Los Angeles. It times together to get a very huge numbers, and this is the distance between New York and Los Angeles. And we square it and come out with a huge number, and then we use this very large result to divide it by this number, and then come out with the gravity number, which is 52.4 millions, about 52.4 millions. Yes, and let us consider two cities which are almost the same size but closer. Let's see what will happen. We consider Guangzhou and Shanghai. Look at those two pictures, two modern cities. And this is the population of Guangzhou, and this is the population of Shanghai. We time it together to get a number which is not that far away from this number. You can see that it's not that far away, but the distance from Guangzhou to Shanghai is almost half of the distance from New York to Los Angeles. And we square it, come out a number, and then we divide this two number, we get a gravity number. We can see this gravity number is much greater than this gravity number. Why? Because the distance changed. The distance of two cities changed, and if in fact to this two gravity number. So let me introduce another idea. Is when the population of two cities is staying constant, the further the two cities is, the smaller the gravity of these two cities. We can see from the graph when the density when the distance of two cities is smaller, and its interaction is very high. When the two cities are far, the interaction is very low. We can see from these two. Let me introduce another example. We can see this is point A, this small point, city A, and city C, this small dot, and city B, a huge city, city A. We consider A is Nansha, and C is Panyu, we say, and the B city maybe we consider it as Beijing, a very huge city, and these two are very small. And so let's we consider if these two interaction is greater, or these two interaction is greater, and we can come out with the answer easily. Since the distance, since in the equation the distance is squared, so we will know that the distance have a greater power over the population. So these two near city will have greater gravity between each other, but not this two or this two. Yeah, and here's a let's say a cons of the gravity of this gravity theory, because lots of people argue that the gravity model can only be used in the old days. Since nowadays the transportation technology developed very much, and it changed people's living style. For example, at the ancient time, if people want to go to a really far city, even though it has a very strong, a very much population, it's hard for us to go there, and it's almost impossible for people to migrate there. and keep surviving. But nowadays, it's very easy for Chinese citizens to just travel to America because the technology is developing. So, how do you guys think about this problem? When the population, the technology, when the technology is developing, um, will the technology environment have a greater effect on those theory? Thank you.